Hi, I want to document a process of making vias after etching and drilling the board. Well, let's call it after etching because like the drilling is kind of sort of the process of making vias. Like it's hard to make vias before drilling. This is one board of a project that I am working on. It is supposed to be a kind of sort of PLC-like controller. This will be running Raspberry Pi and it will be running Python and relatively big display because I need more capability than I have in one of my controllers that used Arduino. So this controller, you can see that the display is quite faded because it's OLED and it does not stand up really that well to the time. This is installed for only 1 year, so I expect that next year it would be even worse readable than it is. And also there is this timer. I am not very happy with it because it's a bit too damp, so it is basically sending cold water to recirculate, or even when it is hot outside. I don't really need to recirculate water that much. Anyway, so basically what I want to do is integrate all this control and make it like a 5 module wide thing and have some kind of maybe other stuff here. Well, you will see probably in the future. Holy shit, I'm ranting too much again. Back to the topic. Yeah, vias. So the previous process was that I have used this green mask material to basically, I have laminated it on. So if you look at, for example, this pad, I have exposed like this small area inside the pad. Basically what I wanted to achieve, let's say that this is the FR4 material and there is pad, and well, mask is much bigger than copper what I have, and so I did basically this. And so then what I did, I have drilled hole here, and let's say this is another pad. So I drilled hole through, and again also mask here. So my goal was to basically deposit copper right here, and here, and here, and here, and here. So basically you would end up with something like a rivet. Again, the copper would look like this, deposited one. I guess then the idea was that when I deposit new layer of mask, it would provide even more mechanical like connection of the copper there, I guess, maybe. I don't think there was any idea really, but this is what I did. Now let's talk about the selectivity of the deposition, because if you sensitize the whole board, the copper will be deposited on the whole board. Because I want to deposit copper only inside the hole, I have used tool like this. This is a piece of wire and I have isolated 3 strands which fits exactly into the hole and deposits enough activator solution to activate it. So you can imagine how painful this is to do. So I have basically just a drop of sensitizer solution. I dip this into the drop, then put this inside the drilled hole. So this is for 0.3mm holes, so I need to basically do this under microscope, otherwise I wouldn't be able to do it. Other thing that was not good was the mask usage, because mask does dissolve in the solution of sodium hydroxide, and well, I did not think about this really too much. I just used it and I expected it to like work. But guess what? The plating solution is also alkaline, so it could survive for like 30 minutes, but then it starts disintegrating, and this is not what you want. So I'm going to change this process, and I will draw a board with some copper on it. And what I will do is I will apply very thin layer of mask, and this will be just basic acrylic spray, nothing special. Then I'm going to drill through a hole and then I'm going to submerge this whole thing into the solutions as if you wanted to plate the whole board. So what happens is that the solution of copper will start, the metallic copper will start depositing on basically everywhere, but this will be just a few hundred nanometers wide pretty much. Well, that one was a little bit too thick, but whatever. Anyway, so then what I will do is I will get a sponge and scrub this copper surface off. This means that the copper from here will disappear, and hopefully along with any traces of catalyst that would cause the copper to deposit there. And I will submerge it into the plating solution again. However, sponge does not get here. Maybe it will get here like this, but that's fine. And well, not really, but yeah, let's hope that will be fine. We will see. And it will continue depositing copper inside of holes, but not on the surface. Then, because I'm working with acrylic spray, I can dissolve it with acetone, so that should work. Okay, so it seems that classic 20 minutes at 60 degrees in an oven is enough to create a durable enough coating. After like 10 minutes this is dry to touch, so... Okay, so let's test the acetone treatment now, if I can strip off the coating. I don't expect any problems here because, yeah, it is already pretty much dissolved. Yep, this is definitely metal now. Okay, so the oven is heating up and let's try do it with this thing. Okay, so the holes are drilled. I did not care too much about precision. I will have to do some switcheroo because I have silver solution here, but I want to plate here, so... And also here I have just plain water, but I need to replace it with hydroxide and put the board there after immersion in silver solution, so you know. Let's start plating then, I guess. Okay, so we can already see quite a bit of copper depositing. So in order to not contaminate this solution by the copper that will delaminate from this eventually, I will get this out, scrub it with sponge and bring it in again. And I actually did not use soap, so we'll see how this works. We are 30 minutes in, there have been some more copper growth. There have been a bunch more copper on the bottom side. Oh my god, I have fucking... Oh no. I must have damaged the spray layers somehow. Well... What am I gonna do? This is not so high density board that I couldn't continue. And also the board seems to be protected by the spray still, so I shall continue with this. Okay, so this is pretty much done for probably like an hour. Anyway, I will scrub this once again, but you can see that there will be some ugliness here probably, so we'll see how this comes out. Oh, did not expect this. So maybe the sponge was not even necessary, but I think, yeah, it was necessary. This is just very free copper that precipitated out, I guess you could say. Okay, so I can measure resistance now, and do you see meter? You don't. So there is 0.02 ohms, and just touching probes has 0.03 ohms. Oh, zero. Okay. So there is pretty much zero resistance, measurable resistance with my equipment at least. But this doesn't tell me much at this point because The problem, I'm not sure if this is mechanical or chemical problem, because when you apply mask and when you cure it at 140 degrees Celsius, and again, either the copper somehow mechanically deforms and detaches from the surface, or it oxidizes and the resistance increases. So ideally, I would have plated this more than I have done right now, but well, again, there was problem with the like spray paint resist kinda sort of thing, mask, I guess you could call it. So you could say that this experiment was kinda sort of failure. Well, at least on this side it was, because the spray failed its job, but on this side it worked fine. So in my opinion, it was either insufficient amount of spray, or it could be that I have scrubbed a bit too hard, because I have used fresh sponge with like how would you call it, with the aggressive side. So maybe I could try some more gentle approach of removing copper. Okay, so that's pretty much all I wanted to say right now, and hopefully you will be seeing this board in the future. And I want to make silkscreen printing, and I want to use these Chinese solder mask pastes, I guess you can call them. I think I know how to do this, but I cannot do this with lithography, unfortunately. I need to build a CNC for this with like a laser, so it will be basically a plotter. Even then, these are terrible, but I can try a few things to improve their parameters, I guess you can call it, basically to make it do the job that it is supposed to do. Well, anyway, that will be for another video, so see you then.